In the skies over Europe in 1944, the Luftwaffe ruled the vertical battlefield. Their Bf-109s and FW-190s climbed faster, turned sharper, and seemed unstoppable. The P-47 Thunderbolt, a plane known for its durability and heavy armament, could unleash a devastating hail of bullets with 8 50-caliber machine guns, but it struggled in vertical combat. German fighters could easily outclimb it, and in dogfights at higher altitudes, the Thunderbolt often lagged behind. Pilots called it a lumbering giant, powerful but limited. Early reports from German intelligence described it as a deadly weapon, yet predictable and vulnerable in certain situations. The problem was clear. Allied pilots needed to survive, but surviving was not enough. To dominate the air and protect bombers on deep penetration raids over Germany, the Thunderbolt had to climb faster, reach higher altitudes, and compete with the Luftwaffe's elite pilots. In the winter of 1943, engineers at American aircraft plants faced a challenge that seemed almost impossible: how to give a heavy, propeller-driven plane the vertical performance of lighter, more agile fighters. Time was critical. The air war over Europe was intensifying, and every month of delay meant more lost planes and pilots. American engineers studied every aspect of the P-47's performance. They examined the engine, the aerodynamics, and the limitations of the existing propeller designs. The solution came in the form of a paddle blade propeller. These wide blades could bite into the air more efficiently, improving thrust and climb performance without needing a more powerful engine. Two designs were tested: the Curtiss Electric C-542S and the Hamilton Standard Hydromatic. Both promised dramatic improvements, but the question remained: would it work in real combat, or would it fail when it mattered most? Initial tests were promising. Pilots reported feeling a completely new aircraft under their hands. The Thunderbolt climbed faster, responded sharper, and carried the same devastating firepower it always had. Engineers watched carefully, adjusting blade angles, testing materials, and balancing the propellers for maximum efficiency. It was a race against time. In just 9 months, a design that might have taken years in peacetime was perfected, ready to be sent into battle. By early March 1944, the 56th Fighter Group was preparing for a deep penetration mission over Berlin. This would be the first major test of the paddle blade propeller in actual combat. The pilots knew the risks. German fighters patrolled the skies, and anti-aircraft fire could be deadly. Yet confidence ran high. The plane had been tested, the engines were tuned, and the propellers had proven themselves in training exercises. What remained was the ultimate challenge: confronting the Luftwaffe in their home skies and proving that an engineering solution could change the course of battle. The stage was set. The Thunderbolts would climb higher than ever before, matching German fighters in vertical combat for the first time. The propellers, simple yet revolutionary, held the key. A small innovation, costing just a few $1 million, was about to turn the lumbering giant into a monster of the skies, capable of outclimbing, outshooting, and outmaneuvering planes that once seemed untouchable. The fate of the air war over Europe, at least in part, would be decided by these wide, spinning blades of metal, and the courage of the pilots who trusted them. In March 1944, the 56th Fighter Group took off from their base in England, engines roaring, climbing into a cold gray sky. The mission was daring: escort a formation of bombers deep into Berlin, right through the heart of the Luftwaffe's territory. Pilots knew every minute would test their skill, courage, and the limits of their machines. Yet, for the first time, they flew with the new paddle blade propellers, a modification that promised to change everything. As they approached enemy airspace, the difference was immediately noticeable. The Thunderbolts climbed faster, responding to throttle inputs with unprecedented precision. German fighters, once able to climb above them and dive with deadly advantage, now found themselves facing a plane that could match their altitude gains. The first encounters were tense. FW-190s and Bf-109s swooped from the clouds, expecting easy kills, but met a Thunderbolt formation that held its ground and, in some cases, outmaneuvered them in vertical climbs for the first time.
Francis Gabreski, one of the group's most skilled aces, engaged in his first combat sortie with the upgraded plane. He reported feeling as though the Thunderbolt was alive, responding instantly to every command. He dove and climbed, weaving through enemy fire, and for the first time, the Thunderbolt could escape and counterattack in situations that would have been fatal just months earlier. The German pilots were confused. Intelligence reports later noted that Luftwaffe pilots could not understand how these heavy American fighters had suddenly gained such vertical performance. Throughout the mission, the Thunderbolts proved their worth. Bombers were better protected, enemy aircraft were challenged at every turn, and the pilots' confidence soared. Reports after the mission highlighted not just the effectiveness of the new propellers, but also the impact on morale. American pilots had been flying defensively, always wary of the enemy's height advantage. Now they had the upper hand in climbs, able to dictate engagements and protect the bombers more effectively than ever before. The success of this mission was more than just a tactical victory. It demonstrated the importance of practical engineering solutions in wartime. A relatively inexpensive modification, developed in months, had shifted the balance of air combat. It was not the creation of a new plane or a groundbreaking engine, but a clever adaptation that exploited existing strengths and minimized weaknesses. The Thunderbolt, once lumbering and vulnerable, had become a monster in the skies. As the pilots returned to England, reports were filed, photographs were analyzed, and the engineers who had worked tirelessly on the paddle blade propellers received their first proof of success. The Luftwaffe was puzzled and frustrated. German factories could not replicate the rapid innovation, and pilots had to adjust to a new reality. The Thunderbolt could now fight them on equal footing, and, in many cases, superior. The Berlin mission of March 6, 1944, became a defining moment in air warfare history. It showed how ingenuity, combined with courage, could change outcomes, even in the face of overwhelming odds. From that day forward, the Thunderbolt's reputation shifted. No longer just a durable fighter-bomber, it became a symbol of American engineering, adaptability, and the growing dominance of Allied air power in Europe. After the success over Berlin, the Thunderbolt pilots returned to combat with renewed confidence. Missions became more frequent, more daring, and more consequential. February and March 1944 marked the beginning of what would later be called Big Week, a series of concentrated attacks aimed at crippling German aircraft production and gaining air superiority. The Thunderbolt, now equipped with paddle blade propellers, became a key player in these operations. During these campaigns, the Thunderbolts were no longer just escorts. They took the fight to the Luftwaffe, engaging enemy fighters over industrial zones, rail yards, and airfields. Vertical maneuvers, once a vulnerability, had become a strength. Pilots reported climbing alongside Bf-109s and FW-190s, matching them in altitude, and then diving to strike with devastating accuracy. Enemy aircraft, accustomed to dominating the vertical plane, were suddenly on the defensive. The Germans were puzzled and alarmed. Reports from Luftwaffe intelligence revealed confusion over the sudden improvement in the Thunderbolt's performance. Pilots noted that American fighters now engaged in ways previously thought impossible. The simple propeller modification had turned the Thunderbolt into a formidable adversary, capable of challenging the Luftwaffe's best pilots on their own terms. Francis Gabreski and other aces continued to achieve remarkable results. Each mission added to the growing legend of the Thunderbolt. Stories circulated of planes climbing faster than expected, evading enemy fire, and returning to base with minimal losses. The combination of firepower, durability, and improved vertical performance allowed American pilots to push deeper into enemy territory, striking targets that had been out of reach before. Beyond individual missions, the paddle blade propeller had a strategic impact. Factories producing German aircraft faced relentless pressure, and production lines struggled to keep up with losses inflicted by the now aggressive Thunderbolts. Allied air forces gained not only numerical advantage, but also psychological superiority. The Luftwaffe, once confident in its ability to intercept and destroy American bombers, now faced a threat that could challenge its dominance in the skies. The Thunderbolt's success demonstrated the power of practical innovation in war. Engineers had created a solution that maximized the existing aircraft's potential, proving that careful design and rapid implementation could achieve more than entirely new machines. The paddle blade propeller was inexpensive, effective, and fast to deploy, a rare combination in wartime aviation.
As the war progressed, the Thunderbolt continued to assert its dominance in the European skies. Pilots who had once struggled with climb limitations now exploited their upgraded aircraft's strengths to strike at will. By mid-1944, the combination of firepower, durability, and the paddle blade propellers had fundamentally changed the nature of air combat for the Allies. Missions that had previously seemed impossible became routine, and the Thunderbolt became a symbol of American engineering and tactical ingenuity. The Luftwaffe, initially bewildered by the sudden improvement, scrambled to respond. Reports described pilots' frustration as Thunderbolts matched them in altitude, maneuvered with precision, and delivered lethal attacks. German aircraft production was already under pressure, and these losses further strained their capacity. Attempts to replicate the paddle blade innovation failed to achieve the rapid results seen in the American designs. The advantage, though incremental in engineering terms, was decisive on the battlefield. The impact extended beyond individual missions. During the lead-up to D-Day, Thunderbolts played a crucial role in gaining air superiority, protecting bomber formations, and disrupting German logistics. Pilots like Francis Gabreski and others became legends, their stories reinforcing the aircraft's reputation. Each successful sortie validated months of engineering work, proving that small, practical modifications could dramatically influence large-scale operations. The P-47's performance now inspired confidence not only in its pilots, but across Allied command structures, shaping strategy and planning for critical operations. The success of the paddle blade propeller also highlighted the broader theme of wartime innovation. Rather than designing entirely new aircraft, American engineers leveraged existing platforms, maximizing efficiency and output. It was a testament to resourcefulness, ingenuity, and the ability to adapt quickly under pressure. The Thunderbolt, in its upgraded form, demonstrated that incremental improvements could achieve results that rivaled more ambitious and expensive projects. This approach would influence aircraft design and military engineering long after the war. By the end of the European campaign, the Thunderbolt had secured its place in aviation history. It was no longer merely a heavy fighter, it was a climbing, diving, and firing machine capable of taking on the Luftwaffe's elite. The paddle blade propeller, simple yet revolutionary, had transformed the plane and the pilots who flew it. It was proof that innovation, courage, and determination, even on the smallest scale, could reshape the course of history. In retrospect, the story of the Thunderbolt's transformation is a story of practical genius meeting human bravery. Every climb, every dogfight, and every mission carried the imprint of engineering foresight and pilot skill. The lessons of those skies, how a clever modification can overcome apparent limitations and turn a perceived weakness into strength, remain relevant not only in aviation, but in all endeavors where innovation meets challenge. The Thunderbolt's legacy is clear. Even in the vast, uncertain skies of war, ingenuity and courage can carve a path to victory, one propeller blade at a time.